and signal analysis. This is what we would study in this tutorial. So we will use a WAV file and plot the different curves associated with it and see what functions are required, etc. Okay, so here is the code which we will use to study on the WAV file. So first of all, we'll use the WAV read function, the WAV read function. We'll specify the inputs and the place, and the section which we want to process. Now the format for the WAV read function is given here. Yeah, so this is the syntax of WAV read function. The one which we will use is y equals to y comma fs equals to WAV read file name. So fs is your sample rate and y is our data. So we can see a synopsis of the command over here. So WAV read file name returns the sample rate fs in hertz and the number of bits per sample and bits used to encode. And right, so yeah, so first of all we'll use the WAV read function and we'll save it in x and fx. X is our data, fs is our sample rate. We will specify maximum speech fx and minimum speech fx, fs by 1000 and fs by 50. Okay, now we will plot the waveform. For t equals to 0 to length of x minus 1, we use a subplot and we plot this. After that we will do a fast Fourier transform and we'll plot the spectrum of the bottom 5000 hertz. That's how we'll do it over here, and then we will plot the spectrum is the DFT of the log spectrum, the discrete Fourier transform. So this is what we do, and then finally we label the plots. So let us see how this code works and what exactly it does. Alright, so let us see what the first code does. Okay, so here is the analysis. First will give us the amplitude versus the time plot, that's the waveform. Here we have the spectrum, and here we have the spectrum, that is the discrete Fourier transform of the spectrum plot. Okay, so the next code that we would use would be here. We'll get a section of the vowel and then we'll use a time of delays, and then we will calculate the autocorrelation. Okay, so let us see what the second code does. Right, so here this is what we have the amplitude versus time, and we also have the correlation coefficient versus the delay. Third code that we would use is we'll get again a section of the vowel, and then we'll plot the waveform. We'll get the linear prediction filter at this time, and we'll plot the frequency response with respect to the filter. So here we go. Yup, so this is the plot of the amplitude. We have the amplitude, the gain over here, the amplitude here, and where in the lower plot we have the LP filter, and this is the plot between the gain and the frequency. So these are the basics of speech signal analysis.